Good afternoon, student. Myself Syed Aslam, Associate Professor in Mechanical Engineering Department of Lord's Institute of Engineering and Technology. Today, I will be delivering lecture on renewable energy sources, and then I will be specifically focusing on one of the renewable energy sources, that is ocean power, right? So we will start. So now my presentation outline is objective of the presentation, then overview of renewable energy sources, then ocean energy, renewable energy and job annual review 2020, and references. Then first of all, the objective of this lecture is to bring scientific awareness about the importance of deployment of renewable energy sources technology in the society and particularly to the engineering community. Then overview of renewable energy sources. We know our electricity production is mostly from fossil fuels such as coal, oil, natural gas and nuclear fuel, which contributes to about 1/3 of global greenhouse gas emissions, right? Therefore, it is essential to provide cleaner and more reliable electricity to raise the standard of living and reduce the air pollution. Then we can say our government is providing strong support, which has brought India as one of the top leaders in the world's most attractive renewable energy sector. So India now has 4th position in the world in using renewable energy. So now we can say 23% of the renewable energy is used in total energy mix in India, whereas in the world 27% renewable energy is used by the world right now. So we have to improve our renewable energy sources total mix in the energy sector. Then next one, we can say all these renewable energy sources, they are completely dependent on solar radiation. That is, primary source of all the renewable energy source is solar radiation, right? This is the main thing. Due to solar radiation, all the renewable energy sources we get, like due to solar radiation, if you use solar radiation using solar thermal conversion and solar photovoltaic, we generate electrical power, that is solar energy. Then using winds are also generated due to solar radiation heating the earth's surface unevenly. So we will see that. So winds are generated. So using the energy in the wind, that is kinetic energy in the wind, using a turbine and generator, we can generate electrical power. Similarly, biomass, that is plants also produce starch or food in the presence of sunlight. We know that. So now we have deliberated on this technology in my earlier lecture. So today I will be focusing my lecture on ocean energy, right? So now next one, we know ocean energy. We utilize tides, we utilize waves, and then we utilize thermal gradient in the oceans to produce electrical power. So now here you can see in deep ocean areas, tides are usually produced, right? They are usually produced in the in deep ocean areas, tides are usually produced. Okay. Then tides are created. How tides are created? Tides are created by rising and falling sea levels through the influence of gravity between the earth, moon and the sun. So these tides are produced because of the gravity effect between the earth, moon and the sun, right? Now we will be focusing on waves. Waves are usually seen in shallower areas of the ocean. Okay, so waves are created when many winds and water influences interact with each other. That is how waves are produced. Waves are produced specifically because of the winds which move over the surface of the ocean. Then, now this ocean energy, we can say ocean wave energy conversion, one type of technology we use, and then second one we use principle of ocean thermal energy conversion. That means the thermal gradient which occurs in the ocean, we use it for generating electrical power. These are the two technologies by which we can generate electrical power using the ocean wave as well as thermal gradient in the ocean water. Then, how are ocean waves converted to electricity? Right? See here, you can see before these ocean waves break on shore, because they will be traveling and then they'll be coming to the shores. Okay, so they have immense energy. These waves have immense energy. You can see here, they pack immense energy. They have immense energy. Then the energy of, we can say the energy of single wave, for example, it could power an electric car for hundreds of miles. So we can imagine how much energy these waves will be having. Okay, so now researchers all over the world, they are working to use this energy and convert it into cost effective and reliable electricity. Now you can say actually this ocean waves energy conversion, this is more popular in US because 50% of the US population living within 50 miles of the coastlines. So America can lead a new energy industry and meet a huge demand with reliable and forecastable clean energy. But how are ocean waves converted to electricity? It is a process that begins with the sun, as I have discussed, because primary source of energy is sun only. Okay. Then, now these are the how these energy we can generate using these waves. So now how waves are produced, this already we have discussed. Again, one more thing, wind blows across the ocean, they creating waves, right? Because wind, when they blow on the oceans, they create waves. We know what is a wave. Has a crest and trough. You see, you can see this one. A wave has a crest and then trough, and then it moves again, crest, thrust. So now, and then this from center position to the top level, this is the amplitude. That means the height of the wave. It moves. Okay, this is known as amplitude, and the distance between two crest or two trough is known as wave length. Okay, and then number of times the waves occur in a second is known as frequency. So this is a type of wave. Okay, so now these waves have frequency and amplitude. Amplitude means height, and interact with each other, the environment and the weather, right? Then these waves encounter, when they encounter the machines which convert the electricity. So now ocean waves are converted to electricity with wave energy converter. We call it as a wave energy converter, WEC. So now these WEC or wave energy converter devices, they are anchored miles offshore in deep water where wave energy is strongest. Now these machines convert waves into electricity. Simply, ocean waves will move a wave energy converter, and that motion drives a generator that creates electricity. This is the method of producing electricity by using this wave energy converter. Then what is this wave energy converter? Wave energy converters are devices that convert, you see, the potential and kinetic energy associated with a moving ocean wave into useful mechanical or electrical energy. So that means these waves, they will be carrying with them this kinetic and potential energy, and that energy is converted into mechanical energy, as well as when they are connected to that, these devices are connected to generator, we generate electrical power. So now wave energy converters can provide clean energy to power the electrical grid, as well as many other applications such as propulsion for ocean vehicles, that means moving the ocean vehicles, or pumping for seawater desalination. We know that desalination means cleaning the water. That means salt water, making it a potable water is known as desalination, removing the salt from the ocean water. Okay, there are many different types of wave energy converters. We will just go through that. Wave energy converters are classified as attenuator, point absorber, oscillating wave surge converter, oscillating water column, overtopping or terminator device, submerged pressure differential, bulge wave, and then rotating mass. These are the different types of wave energy converters which are used right now. Then I am showing here one of the type of this wave energy converter, the operating principle of oscillating water column. This is one type of wave energy converter. Okay, what it has? It has a floating, hollow or fixed device that compresses and decompresses compressed air using the change in wave induced in the water level within the chamber, as shown in the figure. You see here, this is the column here. This is the falling water column, and then here it is raising water column. So inside there will be air chamber. So this air will be sucked, and then it will be compressed and decompressed. Right? So, and then when this air moves in, right, it will be sucked, it will be interacting with the turbine, and then when it is leaving out also, it will be interacting with the turbine, and then turbine is connected to the electrical generator, wherein when the turbine rotates, electrical generator also rotates, and then electrical power is produced. How this is happening? You see, the pressure difference in the chamber forces air to move via a turbine that is coupled with the generator to generate electrical power. This is the technology which this oscillating water column uses, or we can say this is the working principle for oscillating water column converter. Right, next. Then we will see the ocean thermal energy conversion method. We know, we call it as OTEC, ocean thermal energy conversion. So now OTEC, that uses, as I told you, natural temperature difference in oceans to produce clean, reliable electricity day and night year round. That means we are here, this OTEC uses the temperature difference or temperature gradient between the ocean water. That means the surface water will be warm, and then if you go deep into the ocean, maybe around 400 to 500 meters, the temperature there will be very cool. Okay, so now using that temperature difference and using a Rankine cycle, we can produce electrical power. So now the heat from the warm ocean surface and cold from the deep ocean drives the Rankine cycle, which produces electricity. Right? Then the areas for OTEC, where these OTEC are applicable, these conversion technologies, in tropical areas, in tropical as well as equatorial zone, where the ocean temperature difference is at least 20 degrees Celsius. So we can use this technology, right, where the temperature difference between the surface water and the cold water beneath the ocean, some 400 to 500 meters down, is 20 degrees. Okay. So now this OTEC with its base load, that means 24/7, that means it is performing, it can generate this power continuously 24 hours a day and 7 days a week generation capability, and this has a potential to become one of the leading renewable energy sources. That is why this ocean energy also comes under renewable energy sources. So now again it has one more advantage. Along with electricity generation, it can offer the possibility of co-generating other products like efficient seawater air conditioning, right? So we can use that for air conditioning purpose also. And then we can generate, we can desalinate the saline water. Then that is fresh water can be produced, and nutrients for enhanced fish farming and algae production. These are the other possibilities which we can get from this OTEC. Then working principle of OTEC, right? As I told you, OTEC uses the ocean's warm surface water with a temperature of around 25 degrees centigrade to vaporize a working fluid which has a low boiling point such as ammonia, right? So we know that ammonia and freons, they are used in refrigeration and air conditioning as a refrigerant. So here also we can use this ammonia as a refrigerant or working fluid in OTEC to generate electrical power. The vapor, what happens? First, because of the temperature 25 degrees of the surface water, this working fluid ammonia will be vaporized, and then this vapor expands and spins a turbine coupled to the generator producing electricity. You can see here, this is an evaporator where we can evaporate the ammonia or refrigerant, and then this vapor will move, and then it will be rotating the turbine here. Turbine will be rotated, and we know turbine is connected to the generator to generate electrical power. And then the vapor which has been exhausted here, again it goes to the condenser, and then from condenser again it becomes liquid, and then again it goes to the evaporator where again it expands because of the surface water temperature. And then here how the condensation takes place, because now here you can see this red pipe here. This is the hot water, that means we can say 25 degrees centigrade warm water. Using that warm water we are going to vaporize the ammonia, and then once this ammonia is sent to the condenser, then what happens? This cool water from the deep sea we use, because the temperature of the sea water below 500 to 600 meters will be around 5 degrees centigrade. That cool water we will be using in a condenser to condense our working fluid, that is ammonia. So it will become liquid ammonia, and then again liquid ammonia will go to the evaporator, and then it will be evaporated. So this cycle will be repeated continuously. This can be working. So now the condense the working fluid back into the liquid, so it can be reused. Okay. The efficiency of the cycle is strongly determined by the temperature differential. Suppose the temperature difference is more, if temperature gradient is high, then we get higher efficiency. The bigger the temperature difference, higher the efficiency of the plant. Okay, this is one of the conceptual design of an offshore floating OTEC plant. You can see here. Right, then we see now this OTEC power plant we can classify into 3 types, which we will be focusing here. Closed cycle OTEC power plant, open cycle OTEC power plant, and then hybrid OTEC power plant. all have different advantages and disadvantages. Okay, so now first we'll look into closed cycle OTC, ocean thermal energy conversion power plant. Okay, so this is the closed cycle OTC power plant. You can see this is seawater we are using. This is a closed cycle. Okay, so that means here we are having two circuits, right? Here this seawater at room temp at 25 degrees centigrade, it is sent into the evaporator, where evaporator is nothing but evaporator and condensers, or they are the heat exchangers. Okay, so now one more fluid here in the evaporator will be that ammonia or some refrigerant, okay, working fluid. So now because of this temperature of the water at 25 degrees, it will be able to boil the ammonia. So this ammonia will be evaporated, and then it will be sent to the turbine, where it will be rotating the turbine. Vapors of the ammonia will be rotating the turbine, and then we know that turbine is connected to the generator to generate electrical power. Then the exhausted ammonia, it will be transferred to the condenser. As I told you again, condenser is a heat exchanger. Then here you can see in this condenser, seawater at 4 degrees centigrade, it will be supplied into the condenser. It will be passing into the condenser, wherein it condenses. Because of that temperature, this ammonia will be condensed. That means liquid ammonia is formed. Again, transferred using a pump into the evaporator, and then again in the evaporator this ammonia will be vaporized, and then it will be again going to the turbine, and then this cycle will be repeated. This is a closed cycle OTC power plant. So now a 50 kilowatt closed cycle OTC plant was built in Hawaii in 1979 and operated for a few months. Okay. Then second one, a consortium of Japanese companies has also operated a 100 kilowatt closed cycle OTC plant in Nauru. Again, this plant operated for only a few months to prove the concept. This is related with closed cycle OTC power plant. Then we will study about open cycle OTC power plant. Here we are not using any refrigerant. We are not using ammonia. Here the cycle is open. You see here the seawater, which is at 25 degrees, it is flashed into the evaporator. That means we are maintaining some vacuum in the evaporator. So when we maintain some vacuum in the evaporator, what happens? See here, we are using a pump to maintain vacuum in the evaporator. When the seawater at 25 degrees centigrade is sent into the evaporator, it will be flashed into steam. It will be, that means wet steam will be produced here because of the vacuum. Okay, because the pressure drops, and then we know that temperature is related with pressure. So when the pressure inside the evaporator is less, then the seawater will boil and it will become steam. Okay, so that steam is sent into the turbine. Before that, there is a separator which will be separating steam from water. Some water, the steam may be carrying some water particle with it. So that is what a separator does. Separator separates the steam from the liquid water. Okay, and then pure steam will be moving at high pressure, and then it will be rotating the turbine. This is a turbine. Okay, and then because the turbine is rotated, it is connected to the generator to generate electrical power. Now the wet steam, it is condensed, it is sent into the condenser, and then we know that in the condenser what is happening? Seawater, right? Seawater at 4 degrees centigrade, it is supplied into the condenser, and then this steam is condensed again. Okay, so steam is condensed into the water, and then it is re-injected into the sea. So this is an open cycle system, and then here this water which has been flashed into steam, it becomes pure water, because it has been made into the vapor. So we can say this condensed water here, it is potable water. It is potable water. That means we get electrical power as well as we get drinkable water, because that steam which has been generated here in evaporator, it is a pure water vapor. Okay, that water vapor, when it is condensed here, that can be used. That is fresh water we get using this open cycle. Okay, we get electrical power as well as pure water. Then in an open cycle OTC system, the seawater itself is used to provide the thermodynamic fluid. As I told you, seawater itself is used as a working fluid. That is, warm seawater is expanded rapidly in a partially evacuated chamber where some of it flashes to steam. That means part of that water will be flashes is into steam. This steam is then used to drive a steam turbine. From the exhaust of the turbine, the vapor is condensed using cold sea water. Okay? Then the vapor produced by flashing warm seawater is at a relatively low pressure, so it requires a very large turbine to operate effectively. So this is the limitation actually. So this practical limitation mean that the largest open cycle turbine that can be built today is around 2.5 megawatt, much smaller than for a closed cycle system. Okay, so then one of the major advantages, the major advantage of open sea system, cycle system, is that the water condensed from the turbine exhaust is fresh, not salt water, as I told you, and so the plant can also serve as a source of drinking water as well as electricity. That means we are getting, along with electricity, drinking water also, right? A 210 kilowatt open cycle OTC pilot plant operated in Hawaii between 1993 and 1998. Okay, now this is the third one. This is a hybrid system. We are using both the open cycle as well as closed cycle here. That is why it is called as hybrid cycle. Okay, hybrid cycle OTC power plant. See here, this is a seawater. It will be partially evaporated into the evaporator. It is similar to open cycle. Okay, then what will happen? Steam is produced, right? Because partially we are maintaining the vacuum there, so pressure we are reducing, so this water is flashed into steam. Okay, that steam now again second evaporator we are using, where we are having the second working medium, that is ammonia. Okay, so now again, as I told you, evaporator is nothing but it is a heat exchanger. Again, heat exchange between the steam and working fluid ammonia will take place, and then working fluid will vaporize, and then it will be directed to the turbine, where it rotates the turbine, and then this turbine is connected to the generator to generate electrical power. This working fluid, which is ammonia, right, exhaust ammonia, again it is condensed in a condenser using cold sea water, which is at 4 degrees centigrade. So liquid ammonia, again it will be transferred using the pump to the evaporator, and this cycle will be generated, and then again we get this seawater. As I told you, we are using, and then we can get the distilled water or pure water. This steam which has been condensed here, that can be used as a distilled water. So this hybrid cycle is using both the technology of open cycle and closed cycle to generate electrical power as well as generating electrical fresh water. Then This hybrid cycle, why we are using, you see, in hybrid OTEC plant, warm seawater is flashed to produce steam, and then this steam is then employed as a heat source for a closed cycle system. This system is more complex than either of the other cycles, but it has the ability to produce drinking water. These plants are able to generate power and desalinate water simultaneously. That means it can produce saline, from saline water it can produce fresh water or potable water. So these both benefits are achieved through a closed with multiple evaporator stages, being the condensed liquid drinking water of the last chamber, a sub-product of this kind of plant. We have seen here. You see here, in the second evaporator, the steam is condensed and then it becomes potable or distilled water. This is about hybrid OTC power plant. These are the references from which I have made my lecture. Thank you for watching.